And action. All right, welcome back to another fun-filled, action-packed, it's my birthday today, non-flipped Algebra 2 classroom video with me, Coach Goo, now at a fresh age of 22 years old. Yep. All right, okay. All right, so today we're going to be solving equations with E and with ln. This is the exact same thing we've been doing the first 2 days, except now we're adding in E and ln, okay? But the content is the exact same as we've been doing. However, let's make sure we remember what ln is. Does anybody remember what ln, oops, spoiler, what ln is? It's a log. ln is a log, right? It is a log, but what is the base on ln? E. There you go. Yeah, so ln is log with a base of e. That's very important moving forward for this section of notes. All right, so all we're going to do is take a look at a bunch of different types of examples of how you would use this fact to solve some equations. And this is why you need a calculator. So for our first example, it's going to be ln of 2x equals 4. Now remember, we're trying to solve for x here, right? So we're trying to solve for x, but there's something in the way right here. What do we need to cancel out so we can get to the x? ln, right? We want to cancel out ln. So how do you think we can cancel out ln? Base of, wow, very good. Wow, nice. That was unexpectedly fast. Right, that's right. Okay, the base is e this time, right? Normally when you have log base 3 or something, you use the base, whatever that number is, to get rid of it. This time, since the base is e, we're going to use a base of e to cancel out ln. So we got e raised to ln of 2x equals, what do you think is going to be on the right side of this equal sign? E raised to the 4th, that's right. Okay, so now on the left side then, ln, or e raised to the ln is going to cancel out, which leaves you with, and it's approximately, now put that in the calculator and tell me what you get. Remember, let's round it to 2 decimal spots. You're putting e to the 4th in the calculator. So rounding it to 2 decimal spots, and I think Edgar said it, or Alejandro, one of you guys, 54.60. Right, 2x is approximately 54.60. So now, how am I going to solve for x? By 2, right? And so x is approximately? 27.30. All right, there we go. So that is an example of how you would cancel out that ln. So let's do another one similar to this. ln of x plus 5 equals 3. So now, we already did one like this, so can you tell me what you would do first here? Right, use base of e, and why are you doing that again? To cancel ln, very good. Okay, so yeah, the e is going to cancel out the ln. We're left with, is approximately what? Remember, this is where we're rounding, right? We're rounding e to the 3rd, so we're going to use that approximately squiggly equal sign. 20.09. 20.09. All right, and we just have to solve for x, get it by itself. So what should we do? Minus 5, which leaves you with, right, x is approximately 15.09. Very good. All right, our third example is going to be a little different. This time we're going to have e raised to the 3x plus 1 equals 16. So now looking at this one, right, we want to solve for x. We want to get x, down to a normal number. What do you think we need to cancel out this time? E. So how would I cancel out e? ln of both sides. Very good. So we're going to use ln, okay, of e raised to the 3x plus 1 equals, what's on the right side? What do you think? ln of 16. All right, so the ln of e on the left side is going to cancel, right? So we're going to have, and as approximately, we're rounding here, what's ln of 16? 2.77. There we go. So now we're at 3x plus 1 is approximately 2.77. We just need to solve for x now. How would we do that? That gives me 3x is about 1.77. And the last step here. And so x is approximately That's right, 0.59. Very good. Let's do another example similar to this one. Number 4 is going to be e raised to the 2x plus 7 equals 10. So we just did one like this. So what do you think our first step's going to be? Right, ln equals, that's right, equals ln of 10. Very good. So now on the left side, what's going to be left on the left side? Right, because the ln of e cancels out, so we have 2x plus 7 is approximately 2.30. Right, 2.30. And so now we just got to isolate x. We got to get him all by himself. What do we do? Subtract 7. So we have 2x is about negative 4.70. And lastly, which means x is about, that's right, negative 2.35. And there it is. All right, now let's take a look at another problem over here. All right, so we're going to do, this time, it's going to be e raised to the 3x plus 1 equals e raised to the 2x minus 8. Look at this one. Wow. Right, yeah, so there's two ways you can think about this. One way, like you guys are telling me, the mathematical way, you take ln of both sides like this.
Is there another method?
There is another way you can do this, and it's just more about using your sense than... Right, because if you do this, right, ln of e is going to cancel on both sides, right? And then you get what? 3x plus 1 equals 2x minus 8. Right. Now the other way you could think about this is look at the very beginning, right? It says this number on the left side is equal or the same as the number on the right side, right? You see that the bases are the same, right? Which means that the exponents must be the same. If it has to be the exact same number, then the exponents have to be the same, right? So that takes you straight to the 3x plus 1 equals 2x minus 8. Regardless, you're going to get to the same spot, you know? And so then from here, how do you solve for x? Subtract 2x. Right, that's going to keep the x term positive, which is easier than dealing with negatives. And then? And so x equals, that's right. So the next one's going to be very similar using the same concept. ln of 3x plus 5 equals ln of 5x minus 18. So seeing this, what would you write as your next step? Right, you can just bring down terms inside the parentheses. 3x minus 5, or 3x plus 5, sorry, equals 5x minus 18. Because those two numbers have to be the same thing, and for that to be possible, whatever's inside the parentheses on both sides have to be the same. They must equal each other. So then we get 3x plus 5 equals 5x minus 18, and how do we solve that? Subtract 3x. Gives us 5 equals 2x minus 18, and then add 18. We're at 23 equals 2x, and then finally, so my answer is x equals 23 over 2. Very good. You can leave it in a fraction like this because a fraction will be exact. It will be an exact number. Sometimes the decimals you have to round, or it's too long and it's not good. Not as clean. All right, so I'm going to start a new page because this next one could be a little longer. All right, for these next two examples, we're going to be using our log properties. Remember, ln is a logarithm, so we can use the log properties. So for this one, it's going to be ln of x plus ln of 3 equals 2. That's right. So yeah, when you see more than one log, right, you want to combine them into a single log. And then as you said, when you combine these two, it would just be ln of x times 3, which is 3x, right? Right. And then now from here, how would I solve it? Yeah, use the base of e on both sides to cancel the ln. What's on the right side? E squared. All right, so now the e raised to the ln is going to cancel out. Leaves you with? 3x is about 7 point, what'd you say? 7.39, okay? Divide by 3. That is correct. X is approximately 2.46. Very good. Nice. Easy. All right, what about this one then? 2 ln of x minus ln of 7 equals 1. See ya. Wow, very good. Okay, hang on a second. You jumped ahead really far. So common mistake here, right? People want to divide everything by 2. You can't divide by 2 because you have multiple ln terms, okay? If you didn't have that minus ln of 7 right there, sure, you could divide by 2. But because we have multiple log terms, you want to combine them into a single log term. But you can't do that until there's no numbers in front of each log term. So what Omar said to do, what you can use, is the power property, moving the 2 out here in the front into the exponent position, right? So it can change into ln of x squared minus ln of 7 equals 1. And now from here, you see how there's no numbers in front of the ln's, no numbers in front of the logs. Now you can combine them. And when you combine ln of x squared minus ln of 7, what would it be? That's correct. Equals 1. All right, so now from here, what do we want to cancel out? ln, how do we cancel that out? With the e, right? Use the base of e. What's going to be on the right side? E to the first, right? All right, so e raised to the ln is going to cancel. Okay, by the way, let's just pause right here real quick. Let me just ask you, let me riddle you this. Look at the original question, right, at the very top. You see that it says 2 ln of x minus ln of 7 equals 1. We're trying to find x, right? Yeah. However, there's a certain type of answer that x can't be. What kind of number can x not be there? It can't be a negative, right? Why is that? Yeah, you can't take a negative of a log. You can't take a log of a negative. You put that in the calculator, you get a non-real solution. So keep that in mind, right? In your answers, whatever your answer is, it can't be negative here. All right, so now let's continue. So we continue with this. E cancels out with the ln right there. We're left with x squared over 7 is approximately, what is e? 2.72, right? That's that one that you should have in your mind. The approximately, always e, you know, is about 2.72. It's not 3. You multiply by 7 on both sides. 19. If you use the 2.72, it's going to come out to 19.04. If you use the e, then yeah, it's going to be 19.03. Both would be fine. All right, x squared is about 19.04, and then what do I do from here? Square root. Now, you got to consider the answers, right? If you consider the possibilities here, when you take the square root, right, your answers are always what? What are the choices here? Plus or minus, right? So technically, you'd have plus or minus the square root of 19.04, right? However, we already said, you guys already told me earlier, what is your only answer for this question? Positive, right? So your only answer can be x is approximately the positive square root of 19.04, which is what? Okay, 4.36. So this would be your answer. Very good. Nice. And there it is. We're going to do one final example just to avoid confusion. Some people, when they see a problem like this, they tend to think too hard about it, and then it messes them up. So we're going to look at this. So if you're given a problem that looks like ln of e raised to the x plus 11 equals 17, what would you do here? A lot of people, some people, overthink. They make it really complicated, right? A lot of steps. This is a quick problem. Now, why would I say that? Right, because ln of e, that just cancels out, and then we're just left with. That's right. That's a very simple problem, right? What do we do from there? And so x equals, and there you have it. Woo! There it is. So that's going to end these special edition of the notes. And until next time, see you in the next one. Peace! Thank you.